Now, our next topic is the key facts. Which are the facts in oceanic geology and the seafloor spreading? These are the key facts. Now we are going to know about it. The key facts in oceanic geology and the seafloor spreading. The study of oceanic geology and the concept of seafloor spreading both are related to each other because this is the study of geology. So there are several critical facts. The firstly, volcanoes frequently erupt along the mid-oceanic ridges, which releases the abundant lava. When we have learned this chapter, the volcanic eruption, there we have also learned that the igneous rocks can be formed with the help of volcanic eruption, right? The lava or the magma, it forms the igneous rock with the help of cooling and solidification. So the volcanoes when it frequently erupt along the mid-Atlantic oceanic ridge, then it releases abundant, that means a lot of measurements lava. So the rocks on either side of mid-Atlantic ridges, it exhibit the similarities in formation, in their composition, and in their magnetic properties, with the youngest and normally magnetically polarized rocks located closest to the ridges. And as distance from the ridge increases, the rocks become older. Okay, when the ridges are increasing one by one, then the rocks become more older. The oceanic crust rocks are relatively young and no older than 200 million years, in stark to contrast to some continental rocks, and it dated back which year? 3200 million years ago. And the sediment layers on the ocean floors are notably thin and lacking sedimentary sequences older than the 200 million years. If I am writing something over there, that first the volcanoes are coming outside, right? From the volcanic materials, the igneous rocks can be formed. We all know this. After making the igneous rock, from the igneous rock, a lot of materials, it can be a different sedimented zones. These are coming outside, and through the help of different agents like rivers, glaciers, winds, this coming inside or outside, and it's make the layer by layer, the layer wise sedimentation, that is called the sedimentary rock. And because of the sedimentation, the sedimentary rocks are going to be formed. And after that, the PVT changes pressure, velocity and temperature. PVT changes, the different rocks can be formed, which is called the metamorphic rock. So only because of the earthquake activity varies and the sedimentary layers of this, we can have these kinds of sedimentary sequences older than 200 million years. Earthquake activity also varies by location. By deep earthquakes occurring in the oceanic trenches, we can have this information before that, and shallow ones along the mid-ocean ridges. This theory proposed by the Harry Hayes, just now I written the name, he suggests that volcanic eruptions at the ridge crest cause the ocean floor to split over and new lava to wedge in it, and pushing the seabed apart from each other and leading to the seafloor spreading. That is very easy concept. And what is the example is given over there? The mid-Atlantic oceanic ridge is a prime example for this, where continuously volcanic activity we can see over there, which leads to the formation of a new oceanic crust, and it spreads or explains the concept of seafloor spreading, which supports the observations of the rockage and the sediment distribution and also their composition. So what we have learned from the above paragraph, the short pointers. The first which we have learned, the volcanic activity where it's happened in the mid-oceanic ridges. Next we have learned the rock similarities near the ridges. There are some similarities between the rock formation, composition and the magnetic properties. Come to the age gradient of the rocks. Younger rock we can see in the nearby to the ridges area, and the older rock we can see increasing according to the distance. Young oceanic versus older continental crust. These two are significantly younger than the continental crust rocks. And thin ocean floor sediments, which is a lack of old sedimentary sequences. That means there are no layers of the sedimentations properly. Earthquake distribution, that means deep earthquake in the nearby to the trenches and shallow earthquake at the ridges. And who postulated this theory? Harry Hess. Okay, expansion due to the volcanic activity at ridges. That much we have learned today.